Here we go, geometry kids. Today we're going to be looking at 5-3 bisectors in triangles. Okay? So first, we're going to jump right into this. Get right into the theorem. Theorem 5-6. Concurrency of perpendicular bisectors theorem. Okay. Concurrency means concurrent. They have a point they all share, right? So the perpendicular bisectors of the sides of a triangle are concurrent at point equidistance from the vertices. What does that mean? That means if you cut each of the sides of a triangle in half and put a midpoint, and you draw a perpendicular line, and you cut each one in half and draw a perpendicular line, cut in half, draw a perpendicular line from it. They meet up at this point P, which is the same distance away from A, B, and C. Okay, it's right in the middle of those 3 points. So like if you had a coffee shop, a bookstore, and a fireworks factory, and you wanted to put point equidistance from all these, you'd use perpendicular bisectors. Okay. Okay. The point of concurrency is called the circumcenter. Okay. And it's called the circumcenter because if I take this point and I draw a circle, in fact, let's do that. Where's my circle tool? Come on, Mr. Twillier, you know what's going on. I go to make a circle. Use this as my center point. Watch this. Look at that. You have a circle that hits through all those points, or kind of does, as close as it's going to get. Circumcenter, because it's the center of the circle that includes those points. Okay? Circle around it includes all the points of the triangle. Now, the circumcenter can be inside, on, or outside the triangle, which means this point can be in it, on the triangle, or outside it. Notice acute triangles, it's in it. Right triangle, it's on it. And obtuse triangle, it's outside of it. Because again, watch. Watch this crazy, crazy stuff. Circumcenter. Look, it contains all the points. Circumcenter contains all the points about. Circumcenter contains all the points about. Okay? So you're describing that triangle inside that circle. Okay, let's try this thing out. I'm actually going to pause this, kids. And I'm back. Well, you guys think, oh, what are you doing? You guys do know what's going on. So we're going to graph these points. We have the point A, which is 2, 7, over 2, up 7. So that's A. Point B is 10, 7, over 10, up 7, B. And C is over 10, up 3. Then we connect the dots. Boom. Boom. That's not gonna cut it. Okay. Now, step 2. Watch out, moving around. Step 2, we need to draw our perpendicular bisectors. Okay. So I look at AB. What's the midpoint of AB? Well, it's 1, 2, 3, 4, 5, 6, 7, 8, right? Half of 8 is 4. So I cut this in half. 2, 3, 4. And I draw a line. Oops. It's perpendicular. And look, I can follow this line right here, right? Okay. Now, BC. It's half of 4. It's 2. So that's my midpoint. And I draw this line across. So this point is my circumcenter. We're going to call it point P. So there we go. Answer. That's the point 6, 5. There. That's all there is to it, guys. Again, since it's a right triangle, it's going to be on the triangle. Now let's talk about angle bisectors. Now, if I draw my angle bisectors, draw a line that bisects angle B, one that bisects C, one that bisects A, they meet up in this point P such that P is equal distance away from each of the sides of the triangle. And remember, distance is the perpendicular distance. So if I draw a perpendicular, now these aren't perpendicular bisectors, they're just perpendicular. So YC is not necessarily equal to YB. Okay? That is called the incenter. Now this one, we're drawing the circle inside of the triangle and hitting those points. Like we hit X, Y, and Z about. It's not going to be perfect, guys. Okay? So, angle bisectors, incenter, circles inside the triangle. Perpendicular bisectors of the segments, circumcenter, circle surrounds the triangle. You dig it? Okay, a lot of vocab here. Okay, suppose we have this drawing. This is an angle bisector, this is an angle bisector. So Q is going to be an incenter. QN is 5x plus 36. QM is 2x plus 51. Well, if Q is an incenter, then QN is equal to QM. QN equals 5x plus 36. QM is 2x plus 51. Now I just solve it. Subtract my 2x, subtract my 2x, subtract 36, subtract 36, 3x, those cancel, equals 5, 15, so x equals 5. So now am I done? No way, Jose. I take this 5, and I plug it back into my equation. So I go 2 times 5 plus 51, which is 10 plus 51, which is 61, right? If QM is 61, then QO is also 61. And you're done. Now, could QP equal 60? Could that equal 60? What do you think? Could this be 60 if this is 61? No. Because perpendicular is the closest distance, and QP is not closer. So QP is going to be greater than QN, because QN is perpendicular. Okay, so that's the shortest distance. Okay, and there we go. That's where we're going to end it. Enjoy. Arrivederci. All that good stuff.